Howdy everyone, this is Miss Kosh. I am making this video for anyone studying trig, so my IB kids and my AP kids. So I wanted to talk about when we take the inverse of the inverse, what happens. So if we start with sine, here's the inverse of sine. I'm not overly concerned. We can see the domain goes from -1 to 1. The range, this is the point. Let's see if it'll plot for me. Well, sure enough, there it is. It's the point 1 pi over 2. So its range goes from -pi over 2 down here. Can I get that point? Yes, there we go. To -pi over 2 to +pi over 2 is what its range is. So if I want the inverse of the inverse, what I'm doing in essence is I'm switching the x and the y. And when I switch the x and the y, I still have a pretty little piece of this function. Like it's not everything, but it would be the inverse of sine is the sine curve, but the sine curve, let me turn off that inverse, the sine curve itself is a whole lot more. It has an infinite domain. It goes from -infinity to +infinity. It has all real numbers, but if you are looking at the inverse sine and it comes from, if you're looking at the inverse of sine, so if you're looking at a sine function because it came from the inverse of sine, then we have a much smaller piece of that curve. Okay. Likewise, let's see what happens when I have the inverse of cosine. We're looking at this piece right here. My domain goes from -1 to 1. My range goes from 0 to pi. This point, let's see if I can find it. Can I get it to click on for me? Can you see? Oh, hang on. Let me try again. Well, it's pi. There we go. There's pi. So it's -1 pi. So the range is 0 to pi. So when I want to switch x and y and find out what happens here, okay, so I get this piece, which you'll notice is a piece of the entire cosine curve, but not, the inverse itself doesn't get to, I talk about with square roots and stuff that you don't get to grow an arm. It's that sort of idea. We only have this limited amount, this red curve to work with. I only have that to take its inverse, which gives me this blue piece right here. Okay. Likewise, let me turn off those. With tangent, here's the inverse of tangent. It's just one piece living between two asymptotes. When I take the inverse of the inverse, I get just one piece of the tangent curve. But if I look at all of tangent, yeah, that was included, but there's infinitely many of these intervals. Okay, so be careful if you get to an original trig function by way of finding it as the inverse of the inverse, you don't have as big of a domain as you would have had you started with the trig function. I hope that makes sense. Hopefully you were able to see kind of the difference here. The inverse of the inverse doesn't have the same domain as if you had just started with the original function. Okay, good luck. Go study and subscribe. See you later.